To solve this system by substitution, we first need to isolate one of our variables in one of our equations. So we can take the first equation and subtract 5y from both sides. This will give us 3x equals negative 5y plus 11. And then divide both sides of the equation by 3, and we will have isolated x. So we'll have x equals negative 5y plus 11, all divided by 3. And we can take that value for x and plug that into our second equation, substituting it in and eliminating the x variable. So if we plug that in using substitution, we'll have 4 times the whole quantity, negative 5y plus 11 all over 3. And that will be minus 3y equals 5. This is going to equal negative 20y plus 44 over 3. Minus 3y equals 5. And now we can add 3y to both sides of the equation. And that'll give us negative 20y plus 44 over 3 equals 3y plus 5. Now we can get rid of that 3 in the denominator by multiplying both sides of the equation by 3. That's going to give us negative 20y plus 44 on the left and 9y plus 15 on the right. We can then add 20y to both sides of the equation. This is going to give us 44 equals 29y plus 15. And if we subtract 15 from both sides, we'll end up with 29 equals 29y. And dividing both sides of the equation by 29 will give us our first solution, which is that y is going to equal 1. Once we know that, we can plug that value back into one of our previous equations and solve for x. So 3x plus 5 times 1 equals 11. That means 3x plus 5 has to equal 11. And we can subtract 5 from both sides of the equation, leaving us with 3x is equal to 6. And when we divide both sides of the equation by 3, we will have the other final answer, which is that x is equal to 2.